Welcome again, Wildcats. All right, so today we're looking at Thursday, September 22nd. Now, if you notice in my previous videos that this said solving, but upon reflecting, I realized we weren't really solving here, we're graphing. So we're graphing, so you want to erase solving here and put graphing, absolute value, inequalities. And that's going to be on page 14 in your notes. So if you would, pause video and update your table of contents. All right, now that your table of contents is updated, let's look at 14. A little bit of adjustment here. Lots of notes. I'll see if I can get it all in one, but it doesn't look like I can. So what I'm going to have to do is I'll have to do it in sections. So let me line it up here. All right. I think that's the best I can get for right now. So let's look at it. All right. So what I've done in these notes, okay, and I believe I've attached grid paper for you to use, okay, to both examples and some. So you can use that. You can tear that off and use your grid paper for this. Okay, so we're going to look at the four inequalities: less than or equal to, greater than, and greater than equal to. Okay, with respect to graphing absolute value functions. Okay, so or I should say absolute value inequalities. Absolute value inequalities. Okay, so let's look at the first one. So the first one we have let y less than absolute value of x. Okay, so first, since it's less than, I want you to know that when we graph it, it's going to be a dashed line. Okay, so to graph the absolute value of x, we know when x is 0, y is 0. When x is 1, y is 1. When x is 2, y is 2. When x is 3, y is 3. When x is 4, y is 4. So there's your points on the right. And then when x is negative 1, y is 1. When x is negative 2, y is 2. When x is negative 3, y is 3. When x is negative 4, y is 4. Okay, so there's your absolute value parent function. Okay, it's a dashed line because there's no line underneath the inequality. And since it's less than, we shade below. Okay, so if you would pause the video and update your y less than absolute value of x. All right, so now let's look at y less than or equal to the absolute value of x. Now, because there's a line underneath, it's a solid line. And since it's the absolute value of x, this is the parent function. I described how to get the points in this one, so I'm not going to do it again here. Okay. Now, since it's equal again, it's a solid line, and since it's less than, again, it's shaded below. So again, if you would pause the video and update this portion of the notes. All right, so now let's look at the other part of the notes. All right, so now we're looking at y greater than the absolute value of x. And again, the parent function is here. Because there's no line underneath, it's a dashed line. But now, because it's greater than, we shade above. Okay, so pause the video and update your notes. All right, last one. We have y greater than or equal to the absolute value of x. Okay, so again, because there's a line underneath, we know it's a solid line. And because it's greater than, we know it's shaded above. Okay, so pause the video again and update your notes. All right, so as long as you know these four scenarios, you should have no problem completing the examples in the assignment. Okay, all right, so if you would push this aside and let's look at our examples. All right, by now you should start to be feeling very comfortable with graphing because we graph using the transformation. Before I forget, I apologize, I don't always do this in the video. but this is going to be on page 14 as well, and that's going to be in your journal. Okay, so remember, this example page, the example page is always go in your journal. Okay, all right. Now, if you're watching this video, I was gone Tuesday and Wednesday, but I'm back. I'm going to be in class on Thursday and Friday, so I'm not going to do all the examples. But I am going to listen to you. I believe one of the concerns is you want more diverse problems. So I'm going to do, there's 6 examples. I'm going to do 3 of them, which I feel like are diverse. And then I want you to do the other 3 on your own. But again, before we start working on any problems, if you have trouble with that, remember, you can always come to class, and I'm going to do the examples in class as well. Okay, so just remember that. Okay, all right, so let's look at example number 1. Now we know that the parent function starts at 0, 0. So we start there, but the transformation is plus 4, so we need to go left 4. So we go left 1, 2, 3, 4. So this is our new vertex. Okay, we know our slope is 1 divided by 1. So we know we're going from this point up 1 to the right 1, 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 up 1 to the right 1. All right, and then you know with the vertex, it's symmetric, and so there's a mirror image. So we went up 1 to the right 1. Here we're going to go up 1 to the left 1, 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 up 1 to the left 1. Okay, and the reason why I did every point is because it's going to making the dash line easier. What I do to do a dash line is I do dash, space, dash, space, dash, space, dash. Okay, same thing here. Dash, space, dash, space, dash. So you have a dash line. Okay. Now I'm going to put a little bit of color on my graph so that you can distinguish the graph from the shading. You don't have to do this, but it will help distinguish. Okay. So we know it's W of X less than, so we're going to shade below. Feel free to fast forward through my shading if you like. Call it fast shading. While we're shading, give you a little Wildcat factoid. I want you to ask yourself, do you know when Temple High School was established? And to answer that, there is a shirt in my room that has the established date. So something to look for. All right. So now that you have your shading completed, let's look at example 4. Example 4. All right. I think example 4 is a good question to give because it has a negative in front and a minus. So it has a lot more going on, and I think that's a good diverse problem. So first things first, we start at 0, 0. That's the parent function origin, and we're going to do the transformation. So we know plus 4. We know we're going left 4, so 1, 2, 3, 4. But the minus 1 means we're going down 1. So there's our new vertex. Okay? Put a 1 in front and a 1 below, and there's your slope. And we know slope is rise over 1, so the negative 1 means we go down 1, and the positive 1 means we go to the right 1. So down 1 to the right 1, 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 down 1 to the right 1. And we know with the vertex, it's a symmetrical and mirror image. So here we went down 1 to the right 1, we're going to go down 1 to the left 1. Down 1 to the left 1, 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 down 1 to the left 1. Now, because it's greater than or equal to, it's a solid line. And again, I'm going to use color to distinguish the line. So that's actually one of the really things I love about the videos is when I'm teaching in class, you can't see the colors because of all the light and things, but in the video you can always just see the color. Now, because it says it's greater than or equal to, we shade above. So I'm going to shade above. All right. Now, last problem, let's look at example number 5. Now, one of the things, and I try to say it in my videos, but if I forget, one of the things you might try is try an example, or follow me on an example, but on the next one, try it yourself, and then play the video. It's something to think about, okay? So you might pause the video, try one of the examples, in this case, example 5, and then see if you get exactly what I get. All right, so example 5. So again, we start at the origin because that's where the parent function is, and then we follow the transformation. So here it's -4, so we go to the right, 1, 2, 3, 4. Okay, so there's your new vertex. There's a 1/3 in front here, so that's our slope. So that means we go up 1 to the right, 1, 2, 3. Up 1 to the right, 1, 2, 3. And since we know that at the vertex it's symmetrical and it's a mirror image on the other side, we're going to do the opposite. So here we went up 1 to the right, we're going to go here, up 1 to the left, 1, 2, 3. Up 1, 1, 2, 3. Up 1 to the left, 1, 2, 3. Up 1 to the left, 1, 2, 3. All right, now since there's no line underneath, we know it's a dashed line. So again, dash, space, dash, dash. Okay, and that's the benefit of putting all the points because it makes it easier getting the dash. So dash, space, and then dash. All right. Since it's w of x less than, we shade below. There you go. All right, and so I'm going to leave example 2, example 3, and example 6 for you to try. We love bells, right? Love, love, love bells. All right. All right. So now you can try example 2, example 3, example 6. But remember, I will redo all these examples in class. Okay. So that's my way of differentiating for the students that really want the examples before class. They can work on their own, and then the students that want to go over the examples in class, they can ask questions. Okay. So remember that I'm going to go over the examples in class as well. Okay. All right. And the last thing is I really want to make sure you understand is that a great way for a teacher to show their students they care is to listen to them. And I'm hoping that you see that in the videos I've made changes because of some of y'all's recommendations or your concerns and how interact in class. So I get better with feedback. That's part of the learning process. So please, please, please understand I care, and I'll show it by if you tell me something and say, hey, I'm concerned about this, I would like you to try this or this. I'm going to look into it, and if I can, I'm going to apply it so I can give you a better classroom experience, okay? Because you're Wildcat students, and I'm going to be the best Wildcat teacher for you, okay? So with that, have a terrific Wildcat day.